Lesson 1.1.2 Rational and Irrational Numbers and Their Properties. Forward to example 1. Oops. Okay, example 1. Simplify the numeric and algebraic expressions. So first one we're going to look at this one here to the left. We're going to look at this one here first. So we have 3 to the 1/3 power times 5 to the 5/3 power. So now, let me go ahead and rewrite this here. 3 to the 1/3 times 3 to the 5/3. So first thing we notice that both of these bases are the same. Our bases are 3. So now the rule is when our bases are the same and we're multiplying exponents, right, because we're multiplying this 1/3 to this 5/3, we rewrite it as an addition problem. So we're going to have 3 to the 1/3 power plus 5/3. Okay, so we're just adding the exponents. Remember, when you're multiplying like bases, you add the exponents. And simplifying this out, we have like denominator, so we can go ahead and add the numerators. So this would be 3 to the 6/3 power, which simplifies down to 3 squared. Right, 6 divided by 3, simplifying that is 2, which equals 9. Right, 3 times 3, 3 squared, 9. Okay, now let's look at that second problem in example number 1. And I'll go ahead and rewrite this one too. We have a to the 6/5 times a to the 3/2. So we're looking at this. We have like bases, right? They're both a for the bases. So since it's a multiplication problem, we're multiplying our exponents. So we have to rewrite it as an addition problem. So this will be rewritten as a to the 6/5 plus 3/2, or 3/2. Okay, we notice we don't have like denominators, right? Don't have like denominators, so we have to make it so it's like denominators. And I'm going to write it out so we have a little more room down here. So I have 6 to the 5th plus 3/2. Let's see, like denominator, we can just go ahead and multiply the 5 and the 2, right? They have to have something in common. That's 10. So here we did 5 times 2 to get 10, so times 2 on top. So this is going to be 12. Right, you got to multiply the numerator by the same number you multiplied the denominator. Looking at the right side, remember we're adding these. We multiplied by 5 here, so we got to multiply by 5 on top, which would give us 3 times 5, which is 15. And we add them across. So 12 plus 15 is 27 over 10. And we can't simplify that down, right? There's no number that goes into 27 and 10. So our answer would be a to the 27 over 10. Okay. Example 2. Simplify the numeric and algebraic expressions. Okay, so example 2, this first one here, there's a couple ways you can do this. I mean, it looks like you could just put it in a calculator and go ahead and get your answer. But if we're going to use the powers, the root and powers, we got to do a little bit of math first. So 125 to the 3rd power divided by 5. Okay, so we know by rule of our roots and powers, we can rewrite 125. Right, so if we take this 125, we can rewrite this as 5 to the 3rd power raised to the 3rd power, still divided by 5 on bottom. Okay, so these two problems have the same exact value because 5 to the 3rd power is 125, so we're just rewriting it in a different way. But again, it's the same problem. Okay. So now, looking at this problem here. We have an exponent raised to an exponent. There we have 5 to the third power raised to the third power. The rule is when you have an exponent raised to an exponent, we multiply those two numbers. So this 3 and 3, they get multiplied together. So this is actually 5 to the 9th power. Ooh, that's a horrible 9. Divided by 5. Now this 5 has an invisible exponent of 1. Anytime there's not an exponent there, you just assume it's 1. Now where we have like bases, our bases are both 5, and they both have an exponent. So we have 5 to the 9th divided by 5 to the first power. When we have this, we take our exponents and we subtract them. So 9 minus 1 is 8. So our final answer would be 5 to the 8th power, or let me pull out my calculator. 5 to the 8th power is, let's see, 390,625. Okay, so you just got to make sure to see what is the problem asking for, which one of these two answers, whether they wanted an exponent or they want it completely simplified. Okay, let's look at the second problem here. So I'm not going to rewrite this one. I think we can go ahead and do it without it. Oops. So first thing we notice, we have like bases. Both of our bases here are A. And it's being divided. So the rule is when you're dividing exponents, we subtract the exponents. And so we're going to take these two and we're going to subtract them from one another. So we're going to take the 7/9 and subtract it 2/3. Okay. And same things apply. So we look for a common denominator between both of these two fractions. And it looks like 9 can be a common denominator. So we have 9 and we have 9. And keep in mind this is subtraction. So here we multiplied by 1, so you got to multiply by 1 on top. So that fraction stays the same, 7/9. The fraction on the right side, the 2/3, we multiplied by 3 on the bottom, so you got to multiply by 3 at the top. So that's 6/9. So now 7/9 minus 6/9. We're looking at these two fractions here. Those are our two new fractions with common denominators. Is 1/9. So our final answer, remember that our base was A. So our final answer is A to the 1/9 power. Okay, and then remember, you have your power there and you have your root there. So if you do need to ever rewrite it, that's 9A and then just the 1. 1's not really important there. Okay, example 3. So we have solved the equation and categorize the solution as either rational or irrational. Think about if you need a calculator or not. So let me rewrite this one first. So we have x to the 2/5 power equals 3. Okay, so now solving this. In order to, the easiest way to solve this is if we make the exponent here 1, right? So that would give us x by itself. Right? X to the 1 power is just x. Now to do that, we have to raise this, the left side, by the reciprocal of the exponent. So if we have 2/5, we're going to raise it to the 5/2, 5/2. And remember the algebraic rule, what you do to one side, you have to do to the other. So if we raise the left side to the 5/2 power, we got to raise the right side 5/2 as well. So now remember the rule. When we have an exponent raised to an exponent, we multiply them. Right, so we're going to take that 2/5 and multiply it to 5/2, which if we simplify that out is 10/10, which is 1. right? And now we have that exponent of 1 that we wanted, so now we have x by itself on this side. So we have x equals 3 to the 5/2 power. I'll go ahead and write that out before we simplify it. And now we can see whether we can rewrite this, whether it's worth rewriting as a radical. So remember our root and power. That's our power. That's our root. So we can rewrite this as x equals 3 to the 5th power. Okay. And looking at this, if we do 3 to the 5th power, let's see, that would give us 243. Now, if we're looking at 243, there's going to be no number times itself that is going to equal 243, right? Because we're looking for pairs here, right? The rule of the radical. So think about whether you need a calculator or not. For this one, you will need a calculator. So if we go ahead and put this into our calculator, you should get x equals 15.588457.268, and so on, so on, and so on. If we're looking at this, now we have to determine whether this is a rational number or irrational. So remember, if it's rational, it means it ends or it repeats. And it can be written as a fraction. This number here, it's all randomized numbers, which means this is irrational. It's both, it doesn't end, and there's no pattern. Okay, going on to example 4. So now we just solve the equation and categorize the solution as either rational or irrational. Think about if you need a calculator or not. So I'm going to rewrite this problem. So let's see, we got 4x cubed equals 125. Okay, so first thing I'm going to do is I'm going to take this and write it as a exponent. I'm going to rewrite that. We know the 4 is our root and the 3 is our power. Power goes on top, root goes on bottom. So we can rewrite this as x to the 3/4 equals 125. Okay. Remember, the goal is to get x by itself. We want the exponent to be 1. So we have to do the same thing we did in example 3. We have to multiply by the reciprocal here. Oh, sorry, we have to raise it to the reciprocal power. And this is going to be raised to the 4/3 power. Right, so we don't have to simplify this again because we know that that's going to simplify down to 1. So we have x equals 125 to the 4/3 power. Okay, now we focus on the right side, the 125 to the 4/3 power. We can rewrite that using a radical. So we have x equals, that's my power, that's my root. So it's going to be cube root 125 to the 4th power. Now playing around with this a bit, if I do this here first, I know what the cube root of 125 is, right? Because here we're looking for a number times itself is 125. And we know that 5 times 5 times 5 is 125. So this would be 5, right? So all this here would simplify down to 5. And we still have that 4th power. Right? And then 5 to the 4th power, I can't do that in my head, is 625. So if we're looking at this problem, first thing we can do is categorize it as rational, right? Because it's a whole number, right? It ends, it stops. And now think about whether we need a calculator or not. Well, we didn't necessarily need a calculator for this problem. It wasn't too difficult. We end up with the whole number. But again, that 5 to the 4th power was a bit hard. You needed a calculator for that one, most likely. But overall, probably didn't need a calculator for this. We could have solved it by hand.